All right, so that's a picture of what an inverse function is. And now I want to show you that the method of implicit differentiation allows us to compute the derivatives of inverse functions. So let me just say it in general, and then I'll carry it out in particular. So implicit differentiation allows us to find the derivative of any inverse function provided we know the derivative of the function. All right? So let's do that for what is an example which is truly complicated and a little subtle here and has a very pretty answer. So we'll carry out an example here, which is the function y is equal to the inverse tangent. So again, for the inverse tangent, all of the things that we're going to do are going to be based on simplifying this equation by taking the tangent of both sides. So let me remind you, by the way, the inverse tangent is what's also known as arctangent of x. That's just another notation for the same thing. And the way what we're going to use to describe this function is the equation tan y is equal to x. That's what happens when you take the tangent of this function. So this is how we're going to figure out what the function looks like. All right, so first of all, I want to draw it, and then we'll do the computation. Okay? So let's make the diagram first, make the sketch. So I want to do something which is analogous to what I did over here with the square root function. So first of all, I remind you that the tangent function is defined between two values here, which are pi over 2 and minus pi over 2. And it starts out at minus infinity and curves up like this. So that's the function tan x. Okay? And so the one that we have to sketch is this one which we get by reflecting this across the axis, all right? So that's going to be, well, not the axis, sorry, the diagonal, all right? This slope, by the way, should be less, so a little lower here so that we can have it going down and up. All right, so let me show you what it looks like. So on the front end, it's going to look a lot like this one. So this one had curved down, and so the reflection across the diagonal curved up. Here, this is curving up, so the reflection is going to curve down. It's going to look like this. All right, maybe I should, sorry, let's use a different color because it's reversed from what we had before. So I'll just call it green. All right, we'll do this. All right, now the original curve in the first quadrant eventually had an asymptote which was straight up. So this one is going to have an asymptote which is horizontal, and that level is what? What's the highest right there? It's this pi over 2 up here. All right? Now similarly the other way, we're going to do this. And this bottom level is going to be minus pi over 2. So there's the picture of this function. It's defined for all x. So this green guy is y equals tan inverse x. And it's defined all the way from minus infinity to infinity.